My name is Eivind, and I'm here to talk to you a little bit about how you can create a low-cost Synapse data platform. And this is using the serverless part of Synapse, and this is more of a concept. I wouldn't call it a framework or an architecture, but this is sort of a concept for how you can do this. So first, I just want to take you through the slides I'm going to go through now. So first, I'll talk a little bit about why have this concept even come up, why am I talking about this, then what building blocks does this concept consist of, and then after that I'm going to talk a little bit about which parts of Synapse is part of this concept and which parts is not part, and then present a simplistic view of the entire data platform, how you can process your data using these technologies, as well as a very, very minimized example showing how this would look in an actual pipeline in Synapse. And then I'm going to round off with talking about the cost drivers, what makes this expensive or cheap, because this is supposed to be low cost, so we want to keep it that way. Then some challenges that you will have or can have trying to build this, and some reasons why you would want to do this. What are the positive sides of doing this? So let's just jump into it. The use case behind this is you have customers that say, I want a data platform, but I'm cheap. So you want to give them something that doesn't cost a lot and gives them value for, they can get analytics without paying a ton, and a lot of customers, in my experience, have heard about Synapse, and it's very expensive. It's no, be careful. But this is sort of a way to show that it is not that expensive. It doesn't have to be that expensive. So the parts that this solution consists of. So of course there is Synapse. We need Synapse to do the serverless SQL. There is a data lake here, or several, up to you. And I've included an Azure serverless SQL database. I've written it's optional. It's, I would say, it depends on how you want to do things. It is definitely optional, but I would recommend to do it. And I talk about it as if it isn't optional in the rest of the presentation. And then a key vault, you want to keep your secrets safe. Everything here relies on the Parquet format. There is no delta. I'll get back to that. So, Parquet is definitely a part of this. And then, of course, any data platform without good governance, without processes to manage this correctly, it just won't work. And that's especially true for this kind of concept. If you don't do this with the good governance in mind, if you don't structure how you do this well, it's going to be very difficult to manage very, very quickly. So jumping into the Synapse parts, here I've just listed what I would say are the main parts of Synapse. And as you can see, the dedicated pool is not part of this. The Spark engine is also not part of this, neither in notebooks or using mapping data flows. So the only two parts I would say that we use are the serverless SQL and the Synapse pipelines and integration behind them, as well as the orchestration and triggering, all that. So a very simplistic view. This is basically any data platform, more or less, but it's I just wanted to show where this fits in, how they fit together, and expand a little on the data lake side. So you have your sources, as any data platform has, that you want to do something with, and then you want to present them. And here we are using Synapse for the processing, the serving, the orchestrating. We are using the SQL database to store parameters, because we want to have a metadata-driven data platform. We don't want to create 1 million pipelines. We want to create few pipelines, use the metadata that we store in some place, here, SQL, to do this. And then underneath, we see the The different layers, so how I like to build this is using layers, sort of the medallion architecture, where you have a landing zone for your data, ingest, and you have bronze, silver, gold. These have many names. If you go to other talks here, you'll hear them referred to by other names, but yeah. And it depends a bit what people do in them. I'm not going to dive into that because there are others that will cover that in much more depth. But this solution relies on having that kind of structure to keep the governance maintainable, manageable. And then, yeah, presentation here is represented with Excel and Power BI. It could be any other thing. It could you could create APIs on top of this. You could do your analytics or presentation of data however you want. Now, I said we're going to go through some processing options for how you can set this up. So basically, in how I've set this up is in two ways, and I've tried both of these. So you can persist your layers, or you can use virtual layers. And you can see here, data moves from left to right. And if you use virtual layers, this relies very heavily on the serverless SQL, that you create some kind of view on top of your Parquet files that are in the data lake. And on top of that view, you create another view and another view and another view until you're in the presentation layer. And you might ask yourself, why do I bother with all these views? Why can't I just create one view that does everything I want? But that really, it will make it unmanageable if you do that. It will be very hard if you have giant SQL scripts to debug them, to figure out what is actually happening. So that is why it's divided in layers. And then you have the persisted layers. We take data from some kind of source, we put it in our data lake. We have to do this whether it's virtual or persisted. And then with the persisted layers, you do this again and again and again as you go through the different layers, until you have data modeled as you want it, be it in a star schema or otherwise in your gold layer. And all of this is using the metadata from your SQL server to build these layers in a easier way, instead of having to create all of these scripts by hand for each individual table coming from the same source. So how would this actually look? Let's take a look at how you could set this up. So you have your metadata table. This is a very simplified version again. Maybe you have many tables. And in this simplified table, I have some rows. Each row is referring to one field of data from where I ingested it from, and what the names are in each of the different layers. So you can see here we have the field name in ingest, we have the field name in bronze, and in silver. And how you change this, where you change these names and do all of this logic, that is entirely up to you. But yeah, I've chosen to rename my fields here and going to silver. And you have the types as well for each of the different layers. When you ingest something into a Parquet file, often you end up with some nvarchar max or 8000. And you don't necessarily want to keep it that way to make this efficient. Then you have to cast it to something, and here you have what you're casting it to. And this could change between your layers for some reason. Normally it doesn't change so much after bronze, but it could change. And then you want to take this and you want to use this information to build the metadata-driven pipelines. So here is a pipeline, or the picture of a very, very simple pipeline. It just uses two simple tasks. It gets the parameters, that is the first task, gets the parameters from this table, and the second task is the one that actually transforms your data using the serverless SQL and stores it somewhere. So this is based on the persisted way of doing things, where you store your data in the data lake. between each layer. So to just show the get parameters way of doing things, then you have, this is very rudimentary, it's simplified, just keep that in mind. But you select this from your SQL source with a query, and you use the pipeline name as a parameter to get the actual row you want, or rows if it's several rows. Yeah. And then we have to transform the data, and this is using the create external table as a select functionality. So it stores it, saves it for you. The reason to do this is that if you use the copy activity in Synapse, then it will not keep all the statistics from the Parquet file. At least that used to be the case last I checked. So using the SQL serverless way of storing this file lets you keep the metadata on the file, so the statistics, what's the minimum, maximum on these files for each column. So this is also very simplified. It just shows you the how you create this query, and it uses the metadata. Here you can see I just chose the first row and used that first row and showed an example where you use the name in ingest to reference what data is called in the Parquet file. You use the name in silver, or in bronze, sorry, for what you want to rename it to, as well as the type in bronze for how you want to cast it. So you do this with a lot of parameters. You can see this gets quite complex quite quickly, but it lets you build the Parquet files based on the metadata that you have saved in your SQL database. So I know this is very quick, it is very high level talking about something that is complex, but it's hard to do in a 20-minute session, and as well I just want to show like the concept of it. You would have to build on this. When I have done this in the field, I use a lot more logic. The pipeline expression language queries are a lot more complex, and I have pipelines connected to pipelines going from ingest to bronze to silver to gold. And as well, one thing I want to highlight is when you go to the gold layer, often that is, in my experience anyway, very difficult to do with based on metadata. It's hard to join and aggregate and do all kinds of logic you want to do going to your finished structure. So normally I would say I build the gold based on individual queries, but bronze and silver are definitely automated and just uses the metadata, and I generally have one pipeline that brings everything from ingest into bronze, everything from bronze into silver. So cost drivers, what makes this cheap? Because this can be an extremely inexpensive solution if you do it right. Of course, as any data platform, these two statements will be true whatever data platform you're using. So the amount of data stored is going to be important. It scales linearly in a data lake, so it's quite easy to predict. And the amount of data processed is very important, but that is a bit harder to predict, because obviously it depends how often do users refresh this data, how often do they need new data, how much data do you need to process every time you process the data. So of course, given this solution, given what I'm talking about, it would make a whole lot of sense to use incremental loads as much as possible to limit how much you store as much as possible in every layer. And how often you process it would also be very beneficial to limit. So yeah, basically there is some kind of trade-off here. You get to some kind of middle value where you want to persist enough data that it's there for when people ask for it, that you don't have to do a lot of compute, but you don't want to persist more than you have to. And that's why I presented the two different approaches to building this, that you can persist it or do it virtual, and both have their pros and cons. And both rely 100% on using the serverless SQL. So, some challenges. This can become very complex. I've said it already, but it's worth noting. If a customer approaches me and they say, build me the best data platform you can, I will not use this way of doing it. If a customer approaches me and say they want the cheapest data platform possible with a minimal running costs, I say, sure, then this could be an option. So because it's complex and because you have a lot of metadata-driven information, it can be quite hard to troubleshoot if there is something wrong, because so much happens based on queries that in the end it gets tricky to find where did the actual problem occur, what is the problem. And often, since you have your metadata in a SQL table on the side of your Synapse, you have to fix the problem maybe in two places. Maybe you have to tweak the metadata a bit, maybe you have to tweak your pipeline a bit to make this work. One challenge is that you can only do SQL transformation. So, as Simon was saying here earlier, you have JSON. It's quite widespread now. JSON in SQL is not fun. You can do it, it's possible. And you can use serverless SQL for this. But when it gets nested, it doesn't get very fun. And then you have your, it requires a separate metadata store. I call this a challenge because it requires you to keep two different places synchronized. The information needs to work between them. And this is where it, as I said, gets complex when it goes from one to the other. They integrate with each other in ways that are, for anyone that hasn't used this solution before, it can be difficult to navigate the back and forth between the parameters and the Synapse pipelines. There's no Delta format here. You can't use that with these services. Delta format could help you a lot if you could use the serverless part for that. The serverless part can, of course, read the Delta format, but it can't write it. And we are doing the transformations here, which is heavily reliant on writing data. You cannot stream, and even if you've set up something to run very quickly, you immediately hit the part where for Synapse serverless, you pay per amount of data processed, and streaming data, processing it all the time, will very quickly incur a cost that you don't want to see. You have to build all the logic yourself. There is no out of the box. You don't get the governance with this. It doesn't just come for free. You have to build it all, and you have to maintain your data. You have to maintain the storage. So if there is some GDPR requirements or there is any other things that you need to comply to, then you will have to set up some solutions to maintain this. If you want to update the table, you have to set up some pipeline that goes, updates, reads the table, removes what shouldn't be there or updates it, writes it back into a new Parquet file, and then delete the old Parquet files. So there's a lot of overhead doing it like this. But the reason you want to do this, it can be very inexpensive. You can have solutions that give data to customers infrequently, I would say. If you're doing it more than once a day, then this starts to not be so attractive. But for reporting less than that, you can have some data that you present, and it gives a lot of value to the customer. And it's short time. You can generate this data very quickly because it's all based on view. So if you're good at creating SQL, then then you can very quickly generate the end goal here, just writing SQL on top of SQL to give the customer what they want. And of course, fully support version control, CI/CD, you can do that. And as I said, metadata-driven. And just highlight the last one here, you get the lakehouse layer separation, which gives you a lot of governance that is making this possible, and also, I would say, a good thing. This can prepare you for doing other sort of lakehouse things. Maybe this is your first stepping stone into the cloud, and then this can be a very inexpensive way to try things. That was all I had. Please fill out my feedback form, as that will help me a lot. And if there's any questions, I will be around. You can find me. I'll be here for the rest of the conference as well. So if anyone has any questions related to any of this, please just come find me. And yeah, I hope it was somewhat instructional.